Why, hello there, lovely one. It's me, Helen the Great, and I've got some great quadratic equations for us to do. I've started with a more easy one, and then we look at some more interesting ones. They're not really more complicated, they're just more interesting. This one is a very normal type of quadratic equation. We know that it's got an x squared, so we know that we need to make it equal to 0. And of course, if we're adding 3 over here and we need to get rid of it, we're going to subtract 3 from both sides. But we no longer talk about it like that. We just talk about moving the 3 to the other side. And because the 3 is adding on this side, we're going to subtract it on that side. And now we can do a quadratic equation. First, we need to factorize it. There's no common factor. There's no difference of squares, so we're going to factorize a trinomial. The only factors for x squared are x, and the only factors for 3 are 3 and 1. Yes, I know there's a negative, but I'll put it in later and I'll show you why. So, x times 1 is x. 3 times x is 3x. Now, one of these has to be negative because I need 3 times 1 to be equal to negative 1. Which one of them needs to be negative in order to get to a total of 2? You answered correctly. It's going to be negative x, so that means our 1 must be negative x, and that takes us to 2x. Now, ladies and gentlemen, this over here is called rough calculations. It's not really necessary to show. If I were you, I would do them off to the side of the page somewhere, and then in your next line, write down what the answer is. Well, it's not quite the answer yet, is it? We've just factorized it. Now, the whole theory behind quadratic equations is anything that's multiplied by 0, will equal to 0. So that means we could make that bracket equal to 0, or we could make that one equal to 0. So what values of x will make this first one equal to 0? Hopefully you look at it and you go, oh, well, obviously it's negative 3, but let's show you how to do that algebraically. How do we do that? Well, we say x plus 3, we need it to equal to 0. So let's move the 3 over, and x is equals to negative 3. So that would make this bracket equal to 0, which means 0 times whatever this is just going to be 0. But what if x isn't negative 3? Could we still make this equation equal to 0? The answer is yes, we can, because we can still work with the second bracket. We could make that one equal to 0. So x minus 1 is equals to 0, which means x could be 1. And now we've found the 2 roots of the equation, so that's pretty cool. It's a nice warm-up question, don't you think? The next one. I think I quite like this orange color. Let's work with that next. Okay, we've got something that appears to be factorized, but the problem is we've got this 14 on the other side. And in order to do a quadratic equation and to solve for it, we must have it equal to 0. So let's start by moving the 14 over. Now I know you're already seeing that, oh, we're going to have to multiply out the brackets. Why isn't she doing it yet? Well, I just want to prove the point that we need to multiply out the brackets. The reason why we can't solve this yet is because we need the left-hand side to be one term. And at the moment, our left-hand side is 1 and 2 terms. This is a problem. We can't do anything to factorize it as it is, so let's multiply it out. I'm going to use FOIL. First times first is x squared, then it's outside, negative x, inside, plus 4x, and last is minus 4, and then of course we've got the minus 14. Let's gather our like terms. So now we have x squared plus 3x minus 18 is equals to 0. Okay, because I can see into the future, I know that the factors I want to use are going to be 3 and 6. I could have tried 2 and 9 first, but I just did a little bit of thinking and thought, oh, I've got to get to 3. One of them is going to be negative, so this will work. X times 3 is 3x. 6 times x is 6x. One of these have to be negative because we've got to multiply 6 by 3 to get negative 18. Which one, in order to get to 3x, is going to be negative 3. So that takes us to 0, which is what we want. Not to 0, darling Helen. Let's get rid of that. Doesn't take us to 0. I think I'm just skipping ahead a little. That takes us to 3x, which is what we want. So now we know that our brackets are going to be x plus 6. Why? Because they're on the same line over there. And then x minus 3. So now we have one term. Look at that. One term on this side and one term on that side. Remember, the whole theory behind quadratic equations is if anything is multiplied by 0, it will equal to 0. So that means this could be negative 6, or x could be 3. Not so bad. Okay, the last one. Oh, I love this one. Love, love, love it. Most people would probably look at it and be very upset and then skip to the next one. But not you, because you're in my hands and you'll be fine. Okay, first we're going to multiply out the brackets. So now we've got xp. I suppose I could have written px. And qp. And then I've got qx minus q squared. Okay, let's get it all to the other side. Not because it's a quadratic, but because I'm going to have to solve for x. So it's going to be xp minus qp minus qx plus q squared is equals to 0. Let's gather the x's. So there's a term with x and there's a term with x. And we're going to do that so that we can do some mathematics. It's beautiful. And when you see it, you're going to go, oh, Helen, it's just amazing. How did you think of that? You're just a genius. Well, I'm not. I've just done enough mathematics. Okay, so now what I'm heading towards is grouping. Because if I group this together, I can take out the common factor of x. And I'm just going to do it in one step because I know you know what I'm talking about. So it's xp minus qx, and we've taken out x as a common factor. But now we need to solve for x, and these two are on this side, so let's move them over to the other side. Minus q squared plus qp. And now we divide it by that. So now we have x is equals to, let's rearrange the top, to be qp minus q squared over p minus q. But hold on a second, I can see something happening over here. We can take out a common factor of q, and then we'll be left with p minus q. And now, of course, I'm running out of space, so let's try and make it small. I've got x is equals to q, and it's p minus q over p minus q, and then look at it, lovely one, look what it does. That cancels with that, which means, therefore, x is equals to q. I really, really like that question. I think I might give it in my next test. Anyway, lovely one, it's time to say goodbye. Much love.